Also, they want to make it. Okay, we're going to start with 3-1 today. Get everybody back on track. Let's go 3-1. Green. So we're going to study exponents today. Exponents, you've already studied. The reason why we're talking about it again is because it goes into logarithms, which is the main what we're doing. But without a background of exponents, you cannot do logarithms. Okay? Does that make sense? All right. With that being said, 3-1. What are a couple of types? What are a couple of types of exponents that you've learned in the past? There's two different types mainly. No. Huh? No. Okay. So we have exponential growth. How many of you remember exponential growth? Okay. And then we also have exponential decay. That's when things are getting smaller. Right? So a basic graph of what an exponential growth looks like is this. This is an exponential decay. So it's small starting out, larger as you get to a higher number. So starting out really high, decreasing as you get to a higher number, right? How many of you remember that? You should have learned it secondary 1. Okay, it's been a while, but secondary 1 is the nice place. Okay. So when do I have exponential growth and when do I have exponential decay? Different. Yeah, very close. I didn't like one thing about statement because your exponent, not your exponent, actually your base. Okay, so when your base is greater than 1, I'm going to have growth. Okay, and that should make sense because, like 2. 2 squared is 4. 2 to the third is 8. I'm growing or I'm doubling every time. Okay, what happens when I do, like you said, a fourth? A fourth squared is 16. A fourth cubed is 64. It's getting smaller every time you go larger. So that happens once again when this base value is less than 1 but greater than 0. Let's talk about one thing. Why do I stop at 0? Why am I not just saying greater than 1 and less than 1? Can you tell me a reason? Why am I not even using 1? What was 1 raised to some power always be? 1. 1 is just what we're doing. Why can't I use 0? 0 raised to the power is 0. So, does that make sense? Let me explain why we don't go below. Okay, what's 1/2 to the 4th power? 1/15. What's negative 1/2 to the 4th? It'll be 1/15. What happens when I do 1/2 to the half? Do you remember what the half was? Square root. Just remember that from the last question. Square root. So square root of a half, which is something that they're especially in school this week. But what's 1 negative a half raised to the half? The square root of negative a half, which introduces what? Imaginary. Isn't there an infinite amount of even roots? Think about it. 1/2, 1/4, 3/4, 5/4. Those are all even roots, aren't they? So that would introduce, if I have negative space, a lot of imaginary. So I would have an infinite amount of force. So really, could I graph that? That's the reason why your B value has to be good. Okay? Do you understand why we have to have it greater than 0? So we don't get those imaginary. Okay? Everybody good? Any questions so far? Okay. Oh, by the way, most of you guys have not had a math textbook. I will assign mostly R toward most. And the reason is my friend Bob, back up, has the answer to most R. So use it as a tool and not a crutch. Okay? A crutch can be a very good thing. It can be a bad thing at the same time. If you rely upon it too much, then you never get it strong enough to not use it. Or you can use it as a tool to help you strengthen so that you can be prepared to do it on your own. Use it as a tool. Check your answer. If it's not right, say, okay, why is it not right? What should I do to get to that answer? You just look in the back and write down answers is not easy for that stuff. So use it as a resource. It is something I would look at. Okay? Everybody with me on that? Okay. So, good old Bob. Yeah. We might, it depends. We are a little low on books. So we might take their books back if we've already been online, or the other classes have not been. So if they got online, if they just charge for them, we might just, since we're already on, we might want. But right now, if we have no books, we're going to be doing books most of the time. Just because the reason being is logarithms in online are just not deep enough or thin enough to make it. Kind of scribbling on there is not great, which is mostly what we're 5 more months, people. Woo-hoo! Why? Once again, we're going to continue. Yeah. Otherwise, only do. Yeah. I said, oh, what would you like to have? So I went out to the new school yesterday. Wanted to take a little walk. Who's coming with me? Or. So, what's it? I know, why would you not keep it out there? Well, if you're in the boundary for what? Where do you live, Greg? Sarcovia? Unless there's opportunity. Even if I was in the middle of what's your favorite next question for you to say? Well, I just pick up already working. How exactly one of you guys is a Fab 5? Anyway, so I went out there. I looked at my new classroom. Sorry. Yes and no. They've done a lot of changes from here to Saturday and Saturday. No, it's pretty much. Like I don't have that. The new school doesn't have the office. 2 to the -2. What would that be? 2 to the -2. Sometimes I don't turn it. Let's try some reading. 2 to the 0. 1. 2 to the first. 2. 2 squared. What do we see here? Multiplying by 2. And that's what the exponential does. Is multiply times this number, right? If I go backwards, what's happening? Dividing by 2 shows you what's happening. Sometimes you can't do it. That's how I do it. But if you recall, 2 to the -2 is jump the line! Change the sign. Okay? Okay, I'm going to plot this. Is this an exponential growth or decay? Growth. There's a quarter. There's a half. There's 1. There's 2. There's 4. Oops. I should be going through there. Anyway, why am I not going less than 0? The 2 raised to something, even if it's negative, it's still a very small number, but it's still greater than 0, isn't it? 2 to the negative millionth power is still a very small number. Right? But it's still greater than 0. Can I ever get something to be 0 if my base isn't 0? My end behavior will approach it as it goes to the negative of it. Okay? So there is an asymptote. Everybody with me on that? Okay, what's our domain? Infinity to infinity, because I can use any number I want, right? Range, the lowest I can use. 0, do I cut to 0? No, because I won't be there, so it's parentheses 2 and 2. Everybody there with me? Any questions so far? Okay, let's do a decay graph. Y equals to the half. Is that okay? 1/2 to the half. You guys good with that? This is, you guys know today's the 4th day? And being Thursday, you guys know this is only my second or third time ever. Okay, Fab 5 got sucker again. By the way, this is how I'd even do a third or a fourth or whatever, right? I still pick my Fab 5. Once again, there's each individual parent functions that are different depending on the base. They're pretty similar, correct? So once again, I start with 0. Anything raised to the 0 power. 1. Anything raised to the first power. So, 1/2 squared. So we see it being cut in half as I go down, which is good, right? So that's our base. But as I go backwards, it's faster. Timesing by 2, so this will be 2 and 4. Which makes sense because I have 1 over 2 to the negative 2. I have 2 ways to do it in there. Or to give you an idea of the math that I did. Okay. Yes, sir.
So is 0 to the 0 power?
I'm kind of curious about that. I don't know. Plug in your calculator. See what you get.
Okay, might be 1
I just started thinking about what we were talking about.
Wait. It's impossible.
What is it?
Air. Nope. So many. Right?
There is an exponential decay because I'm moving left to right and everything is smaller. What's a likely example of a decay? That might not be exponential. It might be you could have radioactive decay. When they figure out, like, you've ever heard about how old a dinosaur is? Yeah. They use decay to perform so they figure out how much. I actually brought up a button called carbon. So they bring up how much carbon in that bone at that time. Anyway, you guys get that.
They use carbon dating to figure out rock, not bone.
You get what
I don't know actually.
And it's something like that. I don't know what it's called. It's pretty much. Is it pretty much like going down 10% every year? Start off with $10,000 policy, 1 year at 9,000, every second year at 80,000. Where's exponential growth? Interest, right? Interest, that's where I really like it. I'll find one. That's something that I really do. Something that I tell reporters. Okay, what else? Population can be. Okay, how about bacteria growth? They don't just say every 5 minutes, okay guys, 5 minutes, we're gonna break. All right, now 5 minutes, we're gonna break. All right? Bacteria doesn't do that. What do they do? They continually break, right? Okay, any questions on growth and decay about where it's used? Okay, awesome. I don't really want to graph these next ones because we've talked about it. I quickly do it. But what would you do? How would I graph this guy? What does that do? Stop graph. What do we do? What does that -1 do? Just right one. Remember, optional is What does this do? It's a sub 3. So if I just looked at this and I said, what is your range? Can I figure out my range? What was originally 0, and then we shifted it up 3. So when we go from 3 to infinity. Okay, quickly I'm going to show you guys how I do this. Remember, I do my Fab 5. And then this would be a fourth, a half, 1, 2, 4. And then remember, I do this. What does that do? Just to the right one, so it's negative 1, 0, 1, 2, and 4, 3. Whew. Which is a fourth, a half, 1, 2, 4. What does the 3 do? Up 3. So that would take our y value, correct? Once again, is that anything different than what we studied? Just a different parent function. Oh, the whole reason why I was going to tell you about going out to school, I saw this bumper sticker that some guy put on his school box that I thought was love to, but everybody else thinks you're able. What about that? It's really simple. No problem, baby. Okay. Turn bucket through that. Any questions there? Say her and graph that. Notice what I do is now I put a line at 3. Once again, I can't cross that. I can't go below that. That's my asymptote, right? Does that make sense to everybody? So therefore, negative 1 and that 13/4, which is just right above it. 7 half, 4, 5, and 7's up there, which I can't get through. With me? Any questions? Did the domain change? Still negative 3, did the range change? What is that from? 3 to 2. Yeah. No, because if I at least want to, if I follow the base rule, once again being the base greater than a 0, then I'll count it. Does that make sense to everybody? Okay, another thing I want you guys to talk about. Start fresh today, right? So you guys, so you ran out of time, didn't you, last quarter on doing retakes and stuff. I mean, why do you want to wait till the last one? I don't want to actually test right because that's I can do. But if it's a possibility, it's a score that you could have, I would get to work on the test prep, right? Then you can always go back and study. Okay. No, I just do within the time frame. Hey, we feel good about the starting points and stuff? Okay. Now the next thing we're going to talk about is solving exponentials. Okay, they're a little bit harder. This one's not really hard, but a little bit harder. What would x be there? 3 to what power gives me 9? 2, right? That has to be 2. Let me show you an easier way to think about it. Because one time, maybe you might not know what 243 is, right? Maybe. But we're going to, that's getting into logarithms. But today, we want them to have the same thing. Is that not the same thing? Or you equivalent? Now, if the bases are ever the same, therefore the exponents need to be the same. So let's do a little bit harder one. Let's say I have 3 to the 3x equals 27 to the x minus 5. So x is a little bit harder to find now because I can't say what x do I plug in to make sure these guys equal each other. Okay? So I want them to be the same base. Now you're going to be able to get every equation in the same base. What about 3x equals 4? Is there a place that 3x equals 4? There is. It's not a nice, pretty number. Does that make sense for everyone? Okay. So what I'm gonna do here is, I'm getting the same base. Can 27 be base 3? What is 27? 3 cubed. I'm gonna rewrite it. That's equivalent, just looks different, right? Equivalent but looks different. Now what? What do we do on power to power? We multiply, don't we? 3 to the 3x equals, oh, we make that a 2x, please. Sorry, I can't think that 6 because if not, it would never equal each other. Sorry. Equals 3 to the 6x minus 16. What I did is the power to that power, so I multiplied it, I distributed it through. You see how if they're like bases, I can now solve power. So now they're alike. The bases are alike, so I can set the power equal to. Then just a very basic solve. Any questions? We'll do a little bit harder one. Dig a little deeper. Dig a little deeper. Smile. Miss Thompson, did you move into this lovely, where did you used to go to school? South Carolina. That's my campus. Did you in campus? That's not, we're not, Ricky, there's a nice movie star there. Idol, Captain Idol is over there.
So, I thought about it some more.
Oh. What's up?
Stop thinking, Joe. And so 0 something to the power of 0 is itself divided by itself. So if 2 divided to the power of 0 is 2 divided by 2. Therefore, if it's 0 to the power of 0.
Whoa, what?
Then you go back. Yeah, so 2 to the power of 0 is 2 divided by 2. Yeah. Yeah.
So 0 minus 0.
I don't know.
Like basically subtract, right? What? Don't even go on your.
No, because if you do 2 to the power of negative 2, I guess, then that's 2 divided by 2 divided by 2 divided by 2, and that's where you get. Then that's how you get an answer. I looked it up. I did it on my calculator.
It only goes down in that corner.
What about 4 thirds?
4 thirds. I don't know. It'd be 4 thirds divided by 4 thirds divided by 4 thirds. That's okay.
What? 4 thirds.
Yeah. Well, okay. Let me do. So, yeah.
Oh, so, can 1/32 be a base 4? No. Look, 4 times 4? 16. 16 times 4? 4. So right now, I can't get 32 to do 4. What's another way I can write a 4? You have a half square. And isn't 32 a half to the 6? So you want to find a common base. Even if they can't be a base of each other, they might have a common base in themselves. This is 1 half squared to the 4x minus 3.
Yep, that's right.
This is 1 to the 2 to the 5. We'll talk later. Everybody with me there? You see how they're the same base and both a half of their base? Okay. I like your hair color. Fine. Okay, so now this side is 1/2, and 8x minus 6 equals 1/2 to the 15x minus 5. When you set of equals, when the bases are the same. That's when I can solve, is when the bases are the same. Okay? So therefore, 8x minus 6 equals 16x minus 5. I'm going to subtract and add. -1 is 7x, so x is -1/7, but it's not pretty because I did it. I made that one up. Okay. Okay. Ready to do it? What?
No.
All right. You guys know what the number E is? E is a you have to? Yeah. It's E. Okay. So E is a number like pi. It's an irrational number. But where did it come from? Well, it comes, by the way, 2.718, blah, 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 something like that. I know I always think of something, but never estimate. But you do have a button on your calculator. So, where does E come from? Well, it comes from this formula, where we start plugging in values. Start plugging in 0, start plugging in 1, 10, 100, 1,000. It gets closer and closer and closer. So if I keep getting it even larger, or an infinite amount, it is basically, that's what we're looking for. This is equivalent to when n is infinite. Huh? Don't think so. I forget if it is or not. I don't think that's the goal. Okay. Just understand E is a number. Okay, I'd like you guys to tell me what is E to the pi. So E raised to the pi. How are you going to do so? Well, first of all, most of you guys have the PI calculator. E can be found in two places. One, over above the ln. Now that says e to the x. So whenever I want to raise something to a power, I use that button. But if I am using this e as the first power, I'm going to use the number above the divide sign. Okay? But because I'm going to go ahead and use the 1 with the power, because it's e to the pi, I'm going to go second e, so e to the pi, and pi is above there. I hit enter. It's 23.1406. Second on that. So I'm going to ask you to find a few different ways of values. Just to say, let's even like 4 to the 20th power. And we're going to ask you to do some of those. Any questions? Yes, no? Okay. All right. The next thing we're going to talk about is what we talked about earlier. Money, interest. Okay? Let's say you're kind of lucky, not like your grandma died. My grandma died. So lucky means she's a little stuff for you. My grandma didn't. This is okay. Let me ask you. But sometimes grandma would say, hey, you know, when your dad was here's $4 grand. That'd be nice, huh? Okay? So $4 grand. So in the stipulation though is grandma says you can't use this until you're 21. So there is a stipulation saying you can take it when you're 21 and you have your $4,000, you can take it now but put it into a bank account and get paid. Would you guys rather take it at 21 or take it now and not touch it? Rather take it now and put it in a savings account, right? So then at least they'll get some more money. Let's say I shop around and I find a bank that gives me 6% of what they're okay? 6%. Now, how many of you guys get your statement about every 3 months? You get that level of maybe you're lucky to get a quarter. I did the last time I got 7. That's so expensive. You guys all feel for me. You guys all know the situation. We're all in the same spot. How many of you go spending? Yeah. How many does not have a savings account and don't know what the hell I'm talking about? Okay. So that usually happens 4 times a year. We call that compounding quarterly. There's many different types. You can do compounding bi-monthly, twice a month. Or how many times in a year was that? 24. Compounding daily, 365 times a year. Does that make sense? You could have seconds, but I hope not. Okay? You get what I'm saying, though. Does everybody get what I'm going at? Most banks around here, I actually have grown my last class that they do monthly. You heard it was compounding monthly. That's pretty great. I don't see that very often. Okay? I got mine quarterly. Let's stick with quarterly. Meaning we get our interest 4 times a year. Okay? And for most of you guys, you're 16, 17, so let's go with 4 years. Most of you guys are either 8, 17, or almost 16. But let's just say 4 years. 17 to 20. So let's see how much more money, if we put it into a bank account, how much more money I will get. Because obviously putting it into a savings account is more money. Right? Might be a few pennies, might be $100. So at least that's money I didn't have to work for just by putting it in. Correct? Okay, here's the equation that we have. A equals C parentheses 1 plus R over N to the NT. Okay. With that being said, what do you guys think the P is out of all those numbers over there? It is the 4,000. It's the number that's called our principal. What we start out with. You guys want to find the principal and the first principal and step right in. Because I'm right here. Because you spoke it wrong. It's just a path. The principal was in the path. No, I'll shut up. Okay. This is principal. Okay, so I go 4,000. 1. What do you guys think the R is? That's pretty obvious. The rate. Now I need to write that rate as a decimal. So I have 6%. What is that as a decimal? 0.06. Thank you, Heidi. N. N represents the number of times it compounds in a year. So if I said quarterly, what am I going to put up there? 4. It happens 4 times a year. They say biannually. What does that mean? Twice. Okay, does that make sense? They say weekly. You know what that is? 52. We all understand that stuff? Okay. So we have quarterly. And how many years do we have as well? 4. Now let's go ahead and plug that in. I'll let each of you guys plug that in on your own. I want to see how well you guys do on your own.
We are almost done, actually. How nice is that, huh? Did you try it? Anybody? What do you got? Okay, let's say it out loud. That's it? No pennies? I like my pennies. 942. But notice, what if that was 947? Do they round it up to 95 cents in your bank account? They will always keep all your hundredths. They will always keep it. That's how they can make extra money. You guys actually know how banks work, by the way? So how do banks make money? They take the money that I give them, right? And what do they do to it? And then they give it out to other people, huh? So if everybody, let's say I go through Zions, if every Zions member came up to the bank and said, I want my money, that would not be able to happen. We all understand that? For the fact of the matter, their money is out within loans as well. That's what happened with the Depression, right? People coming. Anyway, so this is how much money. Is it worth it to keep it 4 years in the bank? We just got $1,075. Okay, I'm going to go ahead and just make sure you did it. I personally don't do it as one shot. I follow order of operations. And let me show you what I do. Okay, so I start inside. So I'm going to go, was it 4% or 6%? So 0.06 divided by 4, enter. Then what do I do to that? Add 1, because this is the stuff inside the parentheses, right? Then what do? Raise it to the 16th power. Then multiply it by the 4,000. That's me taking it at one shot. If you don't take it at one shot, I would highly suggest you make sure you use parentheses. That's what it should look like if you do it in one thing. Okay? Any questions there? Okay, there are sometimes people or items grow continuously. Where does continuously come from? Well, it's using E. So, continuously, if you have compounding continuously, you're going to use PERT. Okay, PERT. What's the P stand for still? Principal. What's the R stand for? T. Time in years. We always want to put it in years, right? And E stands for 2.71, right? It's a number. So notice the reason why we use E is because it's basically using this formula, but it's compounding continuously. So what is N? Kind of like infinite, huh? So therefore, that's why it changes into the E, because remember, this is infinite, that is E. Does that make sense to everybody? Any questions? Okay, here's your homework. You're doing 3-1, page, is it 226? Is that what page you guys are on that starts? Can somebody look for me? 1 through 67, odd. You guys have a half hour, but you're also doing 71, 72, yes, sir. Okay, how does this one actually work? Okay, so what happens here, what does this make sense is your rate is what they give you as your R. They give you your annual interest rate. Does that make sense? So if it's 6%, I'm getting 6% over the year. Okay? Now the N tells us the number of times it compounds. So they're only giving us 1.5% every quarter or every 3 months. So that's where the R divided by N comes from. Now how many times over 4 years, if I have compounding quarterly, will I be getting interest? Hence why 4 times 4. Does that answer your question? Okay. Any questions on that one more time? Odds on it, yep. So you're going to start 1 through 67 odds. Notice 72, 82, and 84 are the only ones you will not have answers for because they're the even numbers. Okay, you guys have a half hour. I'd suggest you work really hard. If you guys want to see something, oh, it's all right. I'm not in the mood to talk about it anymore. My other classes got talked about mortgages, about how interest and stuff. I talked about my mortgage. Would you like to see it? No, I mean, I showed them the difference between a 15-year loan and a 30-year loan. Most people don't understand the difference. 67 odd. I was showing them, look how long it takes you to, we start this in 2019, and notice I'm still paying more interest than I am to my principal in a 30-year loan, all the way up to, right, oh, a little bit up. Right there. Nope, one more. May 2034 is the first time I'd pay more to principal than interest. So that's 15 years that you pay more interest. Like, a lot of people don't understand. We were talking about interest and money and stuff. Anyway, a lot of people don't understand. Like, my very first payment on my house, I pay about $2,000, and roughly of that $2,000, only $377 went down to my principal. And then if you change this to a 15-year loan, though, it is $800 more a year. I mean, a month. But look how quick you're starting to pay interest. Your principal more than interest. 6 months. Yep. Pretty crazy, huh? Anyway, just wanted to show that. That wasn't as deep as I did, but ooh, I've been asked to do something. Hey, get working. That's not escape.